So right now, we're going to open up track 2, our 11 o'clock slot, with Maggie speaking about GFCIs in Girl Fault Interrupted.
I forgot I don't have to stand behind that. So, hello DEF CON. If you're here to see sparks and smokes, then you came to the right talk. I'm super I'm super excited to be here to talk to you guys about something that I tripped over, pun intended. But first, let me tell you a little bit about myself. My name is Maggie Jauregui, and I have about 3 years of security experience. First 2 in Mexico, doing a security validation for the graphics driver on the software side, specifically for DirectX 9, 10, and 11. And for the past year, I've been working in the US doing software security validation for wireless innovation applications. And this is my 4th DEF CON, first time speaking, super excited. I come from the most incredible country in the world, and if you haven't been there, you really should. Bucket list it at some point. Most amazing people, food, weather, everything, and I'm having a hard time figuring out why I ever left. I got incredible education as well. I got to participate in math tournaments where I was named 4th best in the country 2 years in a row, and 1st and 2nd best in Jalisco State a couple times. And when I'm not doing techie stuff, I do more artsy stuff. A couple of disclaimers. So everything, all ideas, research, images, everything here is my own, and in no way, shape, or form does it represent anything that on the side of my employers, past, present, or future. And also, like I said, my experience is mostly software, so this has been something that I've been looking at for a few months. So I don't claim myself the GFCI queen of the world, so if you have corrections or suggestions or ideas, I'd be super happy to talk to you guys about them. Okay, and there's a small part of me, or maybe not that small a part of me, that loves the fact that I can start my first DEF CON talk ever with, so I was doing my hair the other day, because I was going to go out on a date, and this guy thought that we would save millions communicating through RF, so we bought a couple walkie-talkies and enough battery so it can even come, and we hadn't really synced as to when to use them, so I was doing my hair to go out, and I thought I heard something in the other room, someone speaking through the radio. So I run over there, and I talk through it. Hello, hello, is anyone there? Nothing. So I come back to the bathroom, and I click the call button to make it buzz on the other side. Brr. And when I do that, the GFCI of my hairdryer on the wall vibrates viciously, out of control, horrible sound, then a spark and smoke. So my jaw dropped. I was like, oh my God, you gotta see this. And yeah, for some reason I thought my hairdryer was dead, so I went and got another one and then tried the same thing. And it worked as well. But devices keep working after you disable the GFCI. It's only the GFCI that I get to affect. So then we needed supplies. Where can we get a whole bunch of hair dryers and stuff? So we thank Goodwill for all the material for the presentation. We got a couple of GFCI sockets, an antenna, a more decent radio, studied for my radio license, got my call name and all. Yeah. And then I started thinking, why would this matter? Or how do these devices interact with us in a day-to-day basis? Because don't get me wrong, if someone can DOS, even temporarily, my hair blow-drying ability in the morning, to me that is an extremely high severity vulnerability, but I wasn't sure that the rest of the world would see it that way. So where are these things? And one of the people that we work with suggested that I look into AFCIs as well. And that kind of put the picture together, because in your house, your outlets, your electricity is basically either protected by GFCIs, AFCIs, sometimes both. So I really focus more on GFCIs, and I'll tell you guys why in a second, but we do go over a little bit of AFCI vulnerability towards RF as well. So why are these things there? They serve two different purposes. GFCIs intend to protect you from electric shock. And they have to do so in a really quick manner. I think they have between 25 and 40 milliseconds to stop, because when the body comes in contact with from 5 to 30 milliamps, then that's when your heart goes into ventricular shock, and that's when your ventricles, instead of contracting the way they normally do, they just kind of spaz out. So yeah, whenever it senses that the electricity, if you think of the circuit as water, and what comes in has to go somewhere, so it has to return. If not the same amount of current is coming in as coming out, then it detects that there's a problem, and it has to be really specific and really quick. So that's what GFCIs do. And AFCIs, on the other hand, are trying to protect your house from catching fire. And it basically, like worn out old cables, if there's a spark anywhere, AFCIs are the ones that are supposed to find it. And they do so by analyzing the waveform of the alternating current. So it has to be smooth, and it's a much more complex little piece of equipment than a GFCI. So code requirements. Every year, the National Electric Code deliberates where we need what. So GFCIs are needed anywhere where people can come into contact with both electric equipment and water. So your bathrooms, pools, hot tubs, kitchens, laundry areas, anything above grade level, unfinished basements or garages, a whole bunch of stuff. And AFCIs pretty much protect everything else. They do overlap in a couple of things, I think kitchen and laundry area. Other than that, like the general living areas, the family rooms, dining rooms, living rooms, bedrooms, sunrooms. I need a sunroom. I live in Oregon. I need sun. Okay. So this is how GFCIs work, their little diagram. And it's really quite simple. It's a little transformer, and there's a magnetic core, a toroid, in the shape of a toroid. And so there's an insulated copper wire that goes around them, and that's just a general normal transformer. And through it go the wires, the hot wire on the way out, and the neutral, or the hot wire on the way in and the neutral on the way out. So according to the right-hand rule, if the currents are going opposite directions and they're the same magnitude, then they should cancel each other out. So there should not be a current in that wire. If it detects a small current in that wire, and it's calibrated specifically to, I think, 3 or 5 milliamps, then the solid-state circuitry will inform the shunt trip to open the circuit, and it'll save you from electrocution. It's really simple electromechanical. So here it is, the right-hand rule, going one way, going the other way. They should cancel each other out. Ooh, but there's also, if you notice in the little toroid, there's two, the hot, the neutral, and there's an extra one for the test button. So if you push the test button, it'll enable that third line, which will imbalance it and trip it, cause a trip. And that's what you're supposed to do to test that the GFCI mechanism is actually working, and they recommend for people to test it often, but how many of you test your GFCIs often? Very good, I'm super impressed. Cool. Okay, and inside there's something called a solenoid. So, oops. This thing where it says shunt trip, used to open circuit, that's what this solenoid is. And there's the coil that goes around the transformer then coils around this little thing, and inside it is like a silver bullet that moves in and out, and there's a spring. So as long as the power is connected, the spring keeps the bullet inside. If it notices, if it gets the signal that there's a little current there that it shouldn't be, then the bullet comes out and it pops the reset button, opening the circuit. So This is the thing that we cause trouble with RF, so that's why I'm going into it. And arc fault. Like I said, you were analyzing waveforms and making sure that they're smooth. It's a lot more complicated, and it does thermal checking, and it does, I think also, some of them do ground fault, and the waveform analyze, and something else, a power surge. And it's a lot. And you're dealing with much higher voltages, and it's a little more scary. So now, some demos. I start with the less impressive one, so just so you know. This is just a regular GFCI plugged into a wall, where this is close range, so we're pointing at it pretty nearby with either a radio or the antenna. And this is what happens. You should be able to see some smoke, but it might not be too noticeable. You see some? There we go. A little bit of smoke. This is the first one. This one, we get a spark. These are both closed. The little box is closed, but then I open it up so we can see what's actually going on inside. This one, we get a spark, so look here. You saw it? That blows it up. That's pretty much it. This is a socket, also close range. You should look at the lead in the corner. There you go, that's off. Do it from the side. Do it from the back. And now across the wall, okay, and confession time. So we were testing these things. First thing I did after testing the 90-degree built into the plug in GFCI was try to find them around the house. So I tested the bathroom ones, the kitchen ones, and then other people's houses, friends, of course, with their consent. Because I consider it like lockpicking. It must be the same. You know, if you do your own, if you buy things to break them apart, then it's okay. But if you're not supposed to go messing around with people, that's not why you get a radio license. No. So, but yeah, at some point testing one of the sockets on the wall, we heard a distant vibration somewhere else. And we're like, what's that? And it was something in the neighbor's house. So we stopped immediately, but we realized we can do it across the walls too. Radio on one side, GFCI on the other. Bad filming. Little delay. Basically the same. And now remote. We got it up to about 3 or 4 yards depending on the device. And yeah, it really depended on the device. Some of them needed to be really close, some could be a little further. And I did get recommendations from people to use a bilateral amplifier, or you can use a huger, bigger antenna with a tripod. But you know, you get to a lot of wattage and it just becomes scary and a little more terroristy. If with this little thing I was affecting if with this thing I was affecting my neighbors, you know, I didn't want to figure out, I don't know, that I could fry a chicken with it. You know, it wasn't really the point. Oh. Okay. So doing a few different pulses, eventually it would burn out. And you can kind of see the button move there. So this is the cool one. So try to see if you can notice the button flying out. This is when you open the GFCI. And when I got here, so the real, so yeah, first thing, I swear everything works. If you go check, everything works. I just had to check to see if they were vulnerable. Everything's vulnerable here. The sockets, the hairdryer, everything. So I just tested them. And then I wanted to show my dad, look, here's what I do. I said, I'll film it. What the hell? And with this one, you get a flying piece of component, like flaming out of it. It almost caught my dad's shirt on fire. Okay. So for the demos later, we have a prepared goon.
Smoking. Wow. Throw aqui.
Yeah. So this is what a fried GFCI looks like. The solenoid, the encapsulation of the wire on the solenoid melts out, making it not a solenoid anymore, so it's not a GFCI anymore, so that's why it stops working. And the device keeps working because what we do is that, let me go back to the diagram of the solenoid. Here. We get the bullet to move because it's expecting, okay, so maybe I should go back to where we were. Sorry about that. So the reason why I didn't try with bigger things is because of the wattage and because it was scary. But we did notice people who have done this before. There was a YouTube video. I thought that would be good enough instead of me trying to jump onto my house and install this huge thing. So okay, cool. So I didn't make this myself, so I can't vouch for its validity, but it's pretty cool. We have an antenna on the top of another house. They're pointing it at the circuit breaker, the AFCIs.
Right down there. There's an antenna right there above the tree. It's a flagpole cam radio antenna.
It's really slow.
It's got a fire up for us.
So it's this antenna on the top of the house. And it's pointing to the circuit breaker of a different house. Or this one.
40 meters, okay.
Cool. It's good enough. And 547. So they pointed at the circuit breaker of a different house.
About 17
this is what
meters
happens.
with a ground, correct? All right. Yeah. You tripped him.
Really slow video.
You could stop hacking the wireless for just 2 minutes, please.
Okay, so you see? So it bounced a whole bunch. So AFCIs are also vulnerable to RF. You just need much lower frequencies and bigger antennas that are more expensive and scarier. So I didn't do that.
That seems like a logical break point.
Okay, you guys know the drill. Round of applause for our first time speaker. Cheers.
Cheers! Good job.
To DEFCON.
To DEFCON. Yeah, so I can't guarantee that there wasn't someone back there, sparking the wires, making this thing trip. You were kind of trusting these YouTube people. But there's also, you know, the National Association.
This is really cool.
Thank you. So yeah, I did find a letter from the National Association of Amateur Radio kind of apologizing because their amateur radio enthusiasts' neighbors were complaining that their AFCI circuit breakers were being tripped. And they did work with Leviton to make a better breaker that would withstand that kind of frequency. So what's going on? Like I said, I only did the directional antenna. That's kind of where I stopped. But the fundamental thing that I'm doing is extending the electromagnetic field that comes from the radio directionally. And then that is captured by the transformer, which creates a current that flows through that wire. And then it makes it believe that there's a ground fault. But it doesn't, things, what? No. Oh yeah, we weaponized it. Purple laser. But when I did this, my antenna wouldn't work because there's so much metal in the hairdryer that it messed up my electromagnetic field, so yeah. I can't say much about my antenna. This is about as much as I can say about my antenna.
That's Mickey before he got his mohawk.
Yep. But look at him now. Okay. So resonance. Things, wires are antennas, we are antennas, and things resonate to a certain frequency. Like, if you grab a tuning fork and you hit it against your leg and then put it up against a guitar, the string of the note that is tuned to the same note as the fork will vibrate, only that one. So things are tuned to resonate to a certain frequency. That's how radios work, too. You modify a metal inside that the amount of twists and the width of it does determine what frequency it vibrates to. Things are made to work at a certain frequency, and I think for 120 volts it's like 60 hertz all around. So we're talking about possibly a distant cousin harmonic that the devices are capturing. And I can do two things. I can either do what I showed you guys where, I should do both. I can either trip it, meaning it was on and now it's off, but I can click the reset button and it'll work again. I don't ruin the GFCI mechanism. Or I can melt it and it'll never work again. It's just hardwired. So that leads me to believe that the different materials and the different designs are either capturing, like resonating exactly to a harmonic that it's expecting, or just something annoying and not quite enough to move the bullet all the way through. So yeah, this is what it looks like on the inside. These are the components that this one, the SCR, that one, we'll talk about it a little bit more. That's the one, this one and probably the C4 are the ones that shoot out. This will be the transformer that's capturing, and this is the solenoid that melts. And yeah, I wanted to go back to the other picture to show you from before. This. So the bullet usually gets the signal it's supposed to and goes all the way through. When I'm giving it kind of a weird frequency that it's not used to, and it's way smaller than what it expects, instead of 60 hertz, it's a lot more. So it moves like a little bit forward and then back, a little bit forward and back, because it's alternating. So it does this, and that's what causes the vibrating sound. And things like this are only supposed to work for so long. Like when you buzz someone in a building, the thing is meant for it to just be a shunt trip, right? You click it and then it's open and the person walks in. If you stand there and you push it, it'll know, because it's not meant to withstand long periods of time. So when we keep annoying it for long enough, it overheats and melts and it stops working. Doo-doo-doo. So yes. Okay, and so I was just admiring my GFCIs, the ones that are vulnerable and the ones that are not. The top ones are susceptible to my attack, the bottom ones aren't. Can anyone guess or see anything that's different between those two things? Yes? Yes. The transformer on the bottom ones is definitely larger and has more turns. Huh? Yeah. So, and there's also a little chip in there, in the top ones. And this is that chip. And I couldn't find these, the actual ones that I had physically. I found a data sheet for one of the patents, and I'll show the patents that I found that are vulnerable and the ones that are not. And that patent led me to a number piece, and I went to go see that. But the ones that I had in my hand were not that number. The data sheet that I found supposedly does protect against. The reason why I think it's vulnerable is because sometimes cheap Chinese electronics will count both positive and negative current. So it's adding up slowly, but it measures that there's more and more current coming through there. If it's only measuring the positives, like it should, then it'll never get to the threshold that it needs, right? So what I think is that this little chip is, we couldn't find the data sheet for it anywhere, is counting both the positive and the negative impulses of the frequency that I'm sending, and therefore conducting the current. If it just looked at the positive, then it wouldn't happen. And these are the SCRs, one of the ones that have jumped up in flames. And it's very, very simple, anode cathode. When the gate gets a little signal, and it's really low, I forget what it was, but a tiny amount of amps, then it'll connect them. So if it notices a little current there, it'll activate the shunt trip. So it connects to the solenoid. And the little ceramic capacitor also had a chunk of it jumped out, and these explode for overheating, overcurrent, or short circuit. In this case, I'm thinking overheating, as we saw that it melts. The GFCI power outlets, really, the most I could get out of them, pretty much, well, the ones built in the wall, the house where I live is 17 years old. And the bad patents that I found are about 15 years old, so it kind of makes sense. But the newer ones that I got at the store were, I could trip them, but I couldn't melt them. And these have concentric transformer coil, which was a different thing that I didn't see anywhere else. The patents, the bad and the good. It seems like there's kind of an equal amount of yeses and nos, but if you look at the count that I found, there is a really popular bad GFCI out there. 1999 patent, so it's 15 years old. And I found it in a whole bunch of things, and across the board, in a lot of different brands. I'm not naming brands, but pretty much all of them. And they're all Chinese, pretty much. Yeah, this was my bag coming in. I was worried that TSA would ruin my presentation, but they didn't. Other cases in which it might be a bad idea, some people don't even know that their stuff is connected to a GFCI. I saw people online saying, for some reason, if I trip this button, the lamp outside will shut off. It's like, what? So if you get a GFCI outlet, the top two screws are to plug into the wall, the hot and the neutral. And the bottom two, you can connect to other plugs or appliances, and it'll make them part of the circuit. So they're also GFCI protected or vulnerable. Relevance. Why could this matter? Well, RFI could be just accidental, that you live near a radio station or an amateur radio enthusiast, or it could be intentional, and it's wireless, it's fingerprint free, although I did read that devices have a very specific frequency, so they could do forensics and match the signal, the bad signal, to the device, but I didn't get into that. So yeah, and that was one of the things that kind of annoyed me from my talk, that I found it was either just annoying trolling where someone's making their guacamole and I'm like, ha, no you can't, or potentially super serious things where it would matter, like someone who lives alone and is elderly and depends on a breathing machine or overnight hemodialysis, or it depends on a machine somehow. That would be bad if they could trip the switches somehow. Yeah, hospitals. I tried not to get into that because it's my first talk and I don't want to anger the wrong people. There's medical grade GFCIs, I did not look into them. And, but also hospitals should have a whole bunch of other things to protect them, right? So if someone attacked their AFCIs, for blackouts, they're prepared for that, and they're staffed, and there's manual overrides. So they should be good, but yes, in public places, it could matter. And just recently, there was a GFI news article about an 8-year-old boy in Lake Conroe in Texas who died electrocuted because a GFI malfunctioned, and it was hardwired. I mean, it was burnt. It didn't work, but it was on. It burnt on. And he was in the water for a total of 15 seconds, I think, before he was pulled out. And the city said that the city limits changed, and that's why they hadn't originally checked for everything to be up to code standards. So that's an example of when it could matter. And for the most part, it won't matter. It's kind of like a life insurance. Like I mean, I guess we're all going to die someday. But you might never need it. I don't know that my life has been saved by my hairdryer countless times, but it's nice to know that if maybe I did need it, then it was there for me, you know? But it's one of those things that when you need it, you really need it. So yes, our solutions are test them often, make sure that button pops up the reset and just reset it again. Updating to newer patents, the newer devices should be better. They would all kind of be vulnerable, but to different frequencies. The newer ones are vulnerable to lower frequencies like they're supposed to, the 60 hertz. And the thing that kind of shocks me is that we've known about this for a long time, and it's been fixed for a long time. So why is it that everything I buy and everywhere I go, I can do this? We should know better, right? Yeah. And yeah, I will be talking to some of these and saying, hey, I mean, I'm guessing older patents means cheaper in mass production, and maybe in a hairdryer, maybe it doesn't matter, but what if, you know? So, and also, if you have a loved one who's home alone or yourself who depends on an electrical appliance being on, just make sure you have other options, like a power generator, batteries, or manual override, so you know you have a wiggle time to react. And another thing that we thought was to do a little Faraday cage grounded encasing covering the thing. That should also be a solution. So now I need my lovely assistant so we can do some of these things. Okay. So for my first trick, what?
Frequency.
So the power outlets, we only found that we could do from really close by, but then we thought, wires are antennas too, and they will conduct an electromagnetic field. So if you do through the wire, like maybe thinking across a wall, you could potentially get to it. There we go. That's one. And now, these two. Oh. Now hair dryer, live, from track 2. Right. I opened these up so we could see something interesting. Ooh.
Josh, why are you standing back there?
And we need the camera. Should we? If the device is on while you're interfering with it, it'll turn off. But then you just unplug it, replug it, and the device works. Should I plug this in?
Yeah, hold on.
No. I had to reset it. Yes. So these have not been tampered with. I just opened them up. I'm trying to get a camera so you can see it. I don't know if it'll be big enough, but we have someone ready with a cup of water just in case. Nothing has ever happened, although, yeah, it's a close call.
Something's got to break.
We sacrificed a PCB and countless hair dryers for the demo gods, but you know how it is.
Plugging in the camera does help.
It is plugged in.
Yeah. Sweat.
What?
Nope.
No. No way.
We could just do it here.
Oh, here we go.
Oh, cool. No?
Nope.
Okay.
Fuck it, we're doing it live.
Yep.
Doing it live. Da-da-da.
Hold it up to the mic because they can hear it.
Oh,
Don't point it at me.
no. I need another mic that's not on my face. And you can do this was one of the more sensitive ones, so you could probably do it from a bit. Oh, do the laser. We have a purple laser.
How many hands do you think he has?
Sorry. If we do it from closer, then maybe we'll get faster.
I swear to God, this is not a hold my beer moment.
No?
Here you go, smoking.
We have magic smoke.
Unplug. You can take it out. Over the other one?
And yeah, I could show. Maybe.
Hold up.
Huh?
Maybe.
Oh,
Go for it.
still works. We could do another one. You guys want to do another one?
Yeah.
Okay, last one. Swear. We have like 6 more, so. Oh, by the way, I thought to make it interesting, whoever tweets me The coolest or most bizarre thing that you can think of that would be bad, that could be done with this by like 4 p.m. I'll get you just off the plane from Mexico, awesome añejo tequila, and I'll give it to you later at the Rio somewhere for your Saturday night partying needs. So tweet me maybe.
There we go.
You all ready?
Better. Thanks to our awesome coworkers and friends who've helped me, given me ideas. We got a cute little blooper. It's like, where'd the antenna go? Oh no! And yeah, Foxy's famous now. That's about it. If you guys have questions or something, I think I have a couple seconds.
If you have any questions, there's a Q&A mic right here. Come to the mic.
KD5 QLN. Have you tried other frequencies besides UHF, like 2 meters?
Oops, I didn't hear that.
Have you tried other frequencies besides UHF, like 2 meters?
2 meters?
Like 120 megahertz.
Besides 2 meters. Anything besides
No,
2 meters?
she's doing
No.
UHF. That's 420.
No.
120 megahertz. I could probably do it.
Yeah, we tried it with the range of the radio, but
Okay.
not much more.
More questions? Come up to the mic.
So this is sort of a shameless plug. You have your technician's license?
Yes.
Should show up tomorrow at noon and get your general or your extra. We're doing amateur radio exams across the hall at the Crypto Privacy Village.
Awesome.
So yeah, if you guys want to do this.
If not, you can catch me later. I hope to meet you guys at a party or hallway near you. Thank you.